In Lesson 8, we're going to multiply using the standard algorithm and check our answers, or check the reasonableness of our answer with estimation. The problem we'll be working with today is 314 times 236. Step 1 is we want to estimate the answer. To do this, we're going to round each factor and then multiply those two rounded numbers. When you're rounding your factors, you most likely will round to the highest place value, which for these two numbers is the hundredths place. So here we have 314, and I know this is closer to 300. And my next number, 236, also rounds down and is closer to 200. Then I would multiply these two rounded numbers together to get my estimated answer. The easy way to do this is you count the zeros, 1, 2, 3, 4, and there's 4 zeros in my answer. 2, 3, 4. And then all that's left for me to multiply are my hundreds, which is 2 and 3 multiplied together is 6. So my estimated answer is going to be 60,000. And as a side note, you can also show this in exponent form. And remember, exponent form is that we're multiplying by an exponent of 10. To put this in exponent form, I take the first number here, 6. And then I count how many decimal places I would move over from the end. So it would be 1, 2, 3, 4. And if I want my new decimal there, I know I'm multiplying 6 times 10 to the 4th power. Step 2 is you want to ask yourself, did we round up or down? This will affect whether your answer and the reasonableness of your answer is greater than or less than your estimation. So in this case, we rounded both of our factors down. So when we're filling in and discovering the reasonableness, we're going to look at this sentence frame. The actual factors are 314 and 236. Were they greater than or less than the rounded factors? For this one, our actual factors are greater than. I'm going to put GT for greater than. So the actual factors were greater than the rounded factors. So the actual answer will be greater than my estimation. So for this problem, our estimation was 60,000. So I know my actual answer will be greater than 60,000. Step 3, now we're going to solve using the standard algorithm. The first number that I always start with is the furthest number on the bottom, and I multiply it by all 3 numbers up top. Because this 6 is still in the ones column, it is still treated as a 6. So let's get started. 6 times 4 is 24. I leave the 4 and I put the 2 up here from the 24. Then I go 6 times 1 is 6. Then I add the top number, which is 8. And finally, I go 6 times 3, which is 18. And I put 18 here. Next, I will move to the second line, but I want to make sure that I cross out the numbers that I used up top here because they no longer apply. Now I'm going to move on to my next number in, and I'm going to multiply that number by all 3 digits up top, starting with the far one here. We also have to remember now that we're in the tens column, this 3 is no longer a 3. It represents 30, and to show that I need to put a 0 down here showing that all my answers are going to be equal to tens. So let's start multiplying. So 3 times 4 is 12. I leave the 2 and carry the 1. And you'll notice that I'm lining up each of my numbers, so when I go to add them all together, I don't have to figure out which one gets added with which. Now I move on to 3 times 1 is 3, plus the 1 up top is 4. Then 3 times 3 is 9. And I don't have any more numbers, so I know I'm done. Before I move on to the next one, I'm going to cross off that 1 so I don't use it again. Now I'm going to move on to my next digit, my bottom number, the 2, and I'm going to do the same thing. I'm going to multiply it by all 3 numbers, starting with the furthest one to the right. I also need to remember that this 2 is not a 2. It is actually 2 in the hundreds column, so it's 200. And to show that it is 200 and that my answer is representative of the hundreds, I'm going to put my 2 zeros down here. Now I'm ready to multiply. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. Once I've multiplied my bottom number by all 3 digits on the top number, I'm going to add all of these columns together. 4 plus 0 is 4. 8 plus 2 is 10, plus 0 is still 10, so I leave my 0 of my 10 and I carry the 1. 1 plus 8 is 9, plus 4 is 13, plus 8 is 21, and I carry the 2. 2 plus 1 is 3, plus 9 is 12, plus 2 is 14, so I leave the 4 and carry the 1, and 1 plus 6 is 7. So my answer using the standard algorithm is 74,104. The final step is to check the reasonableness of your answer, and you're going to do that by comparing it to your estimation. So our answer was 74,104, and we're going to compare it to our estimation of 60,000. Now, they're not super close if you're thinking about in thousands, but what I can compare is that here I'm in the 10,000s column, and I'm also in the 10,000s column down here. If I wasn't in the 10,000s column in my actual answer, I might want to go back and check to see if I did anything wrong. That's one way to check the reasonableness. The other way is by looking back at your sentence frame that you filled in and seeing if your answer is actually greater than your estimation. And we can say here 74,000 is definitely greater than 60,000. So that's another way to check the reasonableness of your answer. If it wasn't greater than, you would want to go back and check your math in your standard algorithm.